Today we're going to be looking more at absolute value, but instead of equations, today we're going to be talking about inequalities. Okay, for example, the absolute value of x is less than or equal to 9. Okay, and if you remember, the absolute value means the distance away from 0. Absolute value is the distance away from 0. So the distance that x is from 0 is less than or equal to 9. Okay, so it's less than or equal to 9 places away from 0. Okay, so that means that x can't be any bigger than 9. Okay, and if we go think the other way, 9 places away from 0 on the negative side would be negative 9. X has to be between basically negative 9 and positive 9. Okay. So now let's graph what this means. What is it? Again, we're looking at the absolute value of x is less than or equal to 9. So what distances can x be from 9? Or what can x be from 0? Okay, it has to be less than or equal to 9 spots away. So if we go 9 places away from 0 in this direction, we come to positive 9. Okay, and we know that x cannot be bigger than that. Okay, and if we go the other way, 9 places away from 0 is negative 9. Okay, so we know that x is in between 9 and negative 9 because its absolute value is less than or equal to 9. Okay, so we're going to graph the intersection. Okay, so we can see, and one thing to remember about absolute value inequalities, whenever you see less than or equal to, that means it's basically going to look the same as an and compound inequality. Okay, or the intersection in between 2 points. Okay, now if we look to the next part of example 1, okay, so instead of less than, it's greater than. So that means the distance x is from 0 has to be more or farther away than 1/4 distance. Okay, so that means x has to be bigger than 1/4, positive 1/4. That would be farther away from 0, or x has to be less than negative 1/4. Okay, because negative 1/4 is also 1/4 places away from 0, and to be farther than that away, okay, x would have to be less than negative 1/4. So when we see greater than or equal to, it's going to be an or compound inequality. Okay, and the graph of that looks like, so if we know the absolute value of x is greater than 1/4, that means the distance away from 0 x has to be more than 1/4 or 1/4 distance away. Okay, that means if we estimate that 1/4 would be approximately right here. Okay, we know that values for x have to be more than that, so this represents farther away from positive 1/4, or this is negative 1/4, so this is also 1/4 away from 0, and anything to the left of this point is also greater than a distance of 1/4. Okay, so in this case, greater than is like an OR compound inequality. It's greater than positive 1/4, or it's less than negative 1/4. Okay, so they're going in opposite directions, and that makes sense if we think of it as in terms of distance from 0. The distance from 0 has to be more than 1/4. Okay, so just quick review, something important that will be important for you to remember. If we have an absolute value that is less than or equal to anything, okay, that is an AND compound inequality. So it will be between two numbers on the number line. Okay. If it is greater than or equal to, it's like an OR compound inequality. Okay, so it will be going in two different directions. Okay, because it's a distance greater than. Okay. Okay. Let's go ahead and look at example 2. The absolute value of 2x minus 7 is less than 9. So right away we know that this is going to be an AND inequality. Okay, because it's less, the distance is less than. Okay, so to solve this, we're going to write, basically rewrite this as a compound inequality. 2x minus 7 is less than positive 9. 2x minus 7 then must be greater than negative 9. Okay, for the distance between 0 and this is less than 9 places away. So either negative 9 or positive 9. Okay, now to solve this, remember a couple of days ago we talked about solving compound inequalities, and we could write this as two separate inequalities. Okay, like this, negative 9 is less than 2x minus 7, and 2x minus 7 is less than 9. And we could solve both of those that way, or we could just keep it all as one, and let me show you how we could solve it without rewriting it as two separate inequalities. Okay, we know in either of these the first step would be to add 7. Okay, and we're adding 7 to both sides. In this case, there's 3 places we have to add 7. We have to add it over here, and we have to add it over here, and of course to the 2x minus 7. Okay, so if we do that, we get negative 9 plus 7 is negative 2. Bring down the signs. 9 plus 7 is 16. Okay. Alright, and then the last step would be to divide everything by 2. Okay. Negative 2 divided by 2 is negative 1. 2x divided by 2 is x. and 16 divided by 2 is 8. Okay, so we end up getting x is less than 8 and greater than -1. Okay, we would have come up with the same thing had we solved both of these individually. Okay, if you prefer to do it that way, that's fine. This could be a faster method for you, though. Okay, so let's graph our solution. Okay, so to graph this, we know x is in between -1 and 8. Since it's not equal to either of those numbers, we use open circles. -1, +8. Okay, and then we're going to connect those. Okay, so we have our graph, and remember this represents the absolute value of x was less than or equal, excuse me, less than 9. Okay, let's take a look at example number 3. This time you'll notice that we have a greater than or equal to sign. But before we do anything else, we need to isolate this absolute value part on the left side, which means we need to add 4 first. Okay, it's greater than or equal to 6. Okay, so greater than, remember, tells us this is going to be an OR compound inequality. Okay, so x plus 8 is greater than or equal to 6. Okay, or x plus 8 is less than or equal to -6. Okay, basically what we do is we flip the sign around and make the other number negative to come up with our other equation. Okay, so these are our two compound inequalities. So to solve this, we're going to subtract 8 from both sides. Okay, I'm running out of room here. But 6 minus 8 is -2. So x is greater than or equal to -2. Okay, or on this side, we subtract 8. -6 minus 8 is -14. So x is less than or equal to -14. And those are our two solutions. X is greater than or equal to -2, or x is less than or equal to 14. Okay, so let's graph. Ends up, x is greater than or equal to -2. And x is less than or equal to -14. Okay, so -14. Okay, so we have our graph like this for this compound inequality. Okay, because we had, or we have distance greater than, and so the arrows are going in opposite directions. Okay, go ahead and solve the checkpoints on the next page and use your big book to complete the information at the bottom of that page.